start with a question. How many of you have ever worked in customer service? Please raise your hand. Quite a few. And how many of you have ever been in contact with customer service? That's customers. Well, almost everyone, right? So what we experience, most of us, as customers, what we experience as customer service, behind the facade is actually a lot of hard work. Companies are constantly trying to reduce the frustration that people go through when they have to spend a lot of time to get their simple issues solved, or when they get routed from one network to another. This is a large problem. But there are a few issues that are in the way. First is that it's really difficult to find good people to work in customer service. This, of course, is an issue everywhere, but it's a bit more difficult in customer service. For example, the average employment time in customer service is about 12 to 14 months, and the average turnover rate there is about 40%. This is made worse by the fact that the turnover rate is actually higher among the top performers. So, in effect, companies are constantly losing their best employees. Now, the second part is that the need for customer service is ever increasing. This can be illustrated by the graph you see. On the x-axis you see the value of the solution to the customer. On the y-axis you see the same thing for the company. On these axes you can map every customer request. These numbers you see are from an analysis done by Elisa. They mapped all their customer contacts to these axes. Now, in the lower left half, you see these frustrating things like technical problems, router restarts, things like that. And the top right corner, you see the high value things like information about new products and requests about information that could be beneficial to everyone. Now, the idea here, what we want to do is we want to completely eliminate that which is in the lower left section, and we want to automate everything that's not in the top right corner, so that people would have more time to spend on the high-value problems. Now, this is, of course, not a news to anyone who's ever managed customer service. So, a lot of companies have been looking at chatbots. But as I think that most of you in this room know, there's a lot more expectation in chatbots than the reality would actually allow. Machines can't really hold a conversation right now. And if they're not tied into the company's systems really well, they can probably only answer simple informational queries, like frequently asked questions, but done with a different UI. And for example, say that you have a slow internet connection and you want to diagnose that, there's going to be a lot of back and forth to understand what the real issue is, to explain your situation and so on. But why do you even have to explain that? What if you didn't have to? After all, the network should know everything about you already, right? So, Mindtitan, in collaboration with Elisa, we came up with a system like that. It's a two-part system, broadly speaking. The first part is a customer-facing chatbot with a human in the loop. And the second part is a set of algorithms that monitor the network data and customer interactions. So we started out with the chatbot, and we figured that as Elisa has accumulated a lot of emails from disgruntled customers who have all kinds of various problems, we figured that we could use that to build the initial classifier for the text, right? After all, people are explaining their problems, they're using the right keywords, the chats are labeled, the emails are labeled, so we could use that, right? Well, not exactly. First, maybe not surprising, is that people talk completely differently in chats than they do in emails. And I'm not just talking about the way they speak, I'm saying they use different keywords. And the second thing is that they make a lot of typos. They make more typos in email than they make in chats, which is kind of surprising. But what it all means is that you can't use a classifier trained on emails on chats. So we had to build a separate system, a human-in-the-loop system from the ground up for that. This goes something like that. All the chats are accumulated and unlabeled. Then these chats are clustered based on similarity, handed to a specialist who then labels all these clusters. These clusters are fed to the model. The model is trained with these clusters so that when a new customer comes in, it already knows what knows about this issue. It can recognize this issue. Now, if the bot is certain enough that it can help the person, it just gives out the response and you're done with it. If no, this chat gets handed off to a human operative. If the human operative can selects the bot's offered solution, this reinforces the clusters, the bot is smarter. If not, it goes back to start the process, and well, the bot is, again, smarter. This system allows the bot to constantly learn from both the human operatives and also from the people about how they speak about certain kinds of issues. This system also helps the human operatives themselves because, as this system is really integrated into all Elisa's key systems, the suggestions it offers, they all already take into account all the background information that we know about the person who has the issue. So, this kind of solves the first part of the problem. This bot can understand if you're having problems with late payments or questions about contracts or so on. But it doesn't really know how the cellular network in general is working out for you. For that, we have to look at the network data. Now, there are a lot of good people that have been looking at the network data for a long time at least. They have been manually diagnosing a lot of issues. But it's a large network. It's not possible that a human can monitor, let alone diagnose everything that's going on there. Now, to make everything more efficient, we could automate everything that's being done by humans and scale it network-wide, generalize it so it can catch more issues, not just the ones that were defined. But I've got a slide about the diagnosis of the issues. There are a lot of factors that go into it. Doing this thing manually is really hard work. So we had to have a machine do these kind of things. So what do we have here? We have all the network logs about every number in the network, and we have incoming customer complaints, which are labeled and so on. So, seems like a supervised learning problem, right? Well, not exactly. There's ambiguity here on 3 levels. First, a customer calls in, but a customer may have multiple cell phone numbers. We don't know which one had issues. A second thing is that we don't know when the issue occurred. It's not likely that you're going to call in the moment you have an issue. After all, it's a cellular network. And the third thing is that we don't know where the issue occurred. Was that your home, at your work, at your country house, on the way to the store? So in essence, we have no idea. It's made even worse by the fact that about 20% of people ever complain about the issues that they're having. The other 80%, they're probably somewhere in the control group, messing it up for me. So how do you solve that? Well, actually, we had 3 approaches that we're using. The first thing is that we mapped everyone for a certain period of time. We mapped where people, the people who had problems and those who didn't, were moving. And we compared the distribution of people who had issues and who didn't. So we saw that at a certain point in time and space, there is a large concentration of people who had issues. This can work as a label. But this is not accurate enough. The second thing we did to get it more accurate is that that Elisa is currently outfitting their employees with applications and devices that measure their connectivity while they move around the country. So we can use these things as labels when we see something anomalous, and we can work back to these labels from the network side. And the third thing, which is a bit different because, like the first 2, you can catch things that were reported or monitored. But for the third one, you would have to catch things that are not reported but are still anomalous behavior. This way you can catch, for example, devices that are a bad fit for the network or that are simply malfunctioning. These, of course, go to an analyst who actually labels the anomalous behavior. These labels are then fed back to the system, and it makes the bot smarter. We can talk about it more in depth at the workshop that we're having today. It's 3:30. Come there, we're going to have fun. This whole system, it works it ties back into the chatbot as an extra information layer. For example, if the system can diagnose an issue, and this can be solved by the techs behind the scenes, it will be done behind the scenes, and the person will never be the wiser. If it requires some input from the customer themselves, the chatbot will let them know, tell them about the next steps that they can do to improve their own experience. And again, problem solved. This whole system, it improves customer experience, improves Elisa's customer service in 3 different ways. First, we can resolve the issues proactively, in the sense that we can resolve your issue before you know that you're having it. The second is that we can speed up the solving the issues that we couldn't proactively eliminate. And the third is that we can involve people only when we really need to. There are some issues that really require human contact, and now people have more time to spend time on these kinds of issues. This is all not, in a sense, novel idea. There are a lot of companies facing the same issues that Elisa is facing today. And there are a lot of smart people trying to solve this. But this kind of plan requires a lot of collaboration between the executives, the engineers, the customer service people, the data scientists, and this is hard to come by in anything that's larger than a startup. But I think that with Elisa, Mindtitan has that kind of collaboration. That's why I think that we could pull that off. And kind of totally expected, but still a fun fact, is that less stress makes happier people. And studies show that people who are in contact with happier customer service people are happier themselves. And well, I'm all for happier people. So I hope that all endeavors, such as ours, come to fruition. Thank you.
What a great talk, Markus. It sure did put things into perspective.
So you see, AI
I hope you have enjoyed the program so far. I sure have. It is now time.
Sorry, what was the question?
Her name is Elisa, by the way. So still, I'm the one asking the questions. How did you solve the privacy concern when using Elisa's data in Mindtitan?
Well, when you do the network analysis type of thing, you don't really need to know what the numbers are behind that, right? What I care about is an identifier. So we work with data that doesn't really have any personally identifiable information there.
Okay. Is it a good idea to give advanced chatbots the capability not only to collect and analyze the data, but also to take actions instead of human in customer support?
Oh, well,
what kind of actions?
Let's say, if you want the bot to actually take an action, there are a few steps it has to go through. Of course, there are some things that you're not going to allow the bot to do. You're not going to allow the bot to buy you a new cell phone or something like that. In things like that, you usually direct the person to a page where they have to do the action themselves, so they are really aware of what's really going on. You can do the simpler things, maybe bot tells you can I configure your stuff so it works better, and you say yes, okay, I can do that, because you can roll that back. But when the hard stuff, like financial transactions, no, in that case, it has to be very explicit that the person really wants that.
But still, you can give away phones for free, for example.
Well, yeah, you can always give phones out for free. You can talk to Elisa about that.
How many percent of issues are solved by AI in Elisa? Do you have any statistics?
I don't think I have the exact statistics right now. We're doing the simple stuff right now. We're collecting the chats about different issues takes a long time, and there are so many different issues that you can have when you're running a telecom business. So if you want the exact lowdown of what exactly the bot is answering and so on, you should go find Robert. He's easy to find. He's the tall, handsome guy. Somewhere here. I can't see. Well, you should find him and ask him.
Okay. And the last question. What's your process for finding problems where machine learning could be worthwhile?
I'm sorry, what's the...
How you find where to solve any problems using machine learning? What are the best ways to identify the right fields?
Well, that's an interesting question, because we started Mindtitan because we're a bunch of engineers. We don't know what the problems are that really need to be solved. So when people come to us, they have probably a set of pain points, they have a set of issues, and we usually run a workshop with them so that we try to understand where you can fit machine learning into it, and even if it is worthwhile at all. Sometimes the problems that people are facing, they're not solvable by machine learning. Or you can solve it only by, let's say, 60% accuracy, but it only makes sense if it's at least 90. And sometimes it's just cheaper to have people there. Maybe the machine learning project would take 2 years and cost $1 billion, then it's easier to just have a person do that.
Okay, so you're not proactively looking for different issues. You have a lot of existing problems to deal with.
We have quite a bit of existing problems, yes.
Cool. Thank you.
Thank you.